Hi dear, we are nearly coming to the end of this journey. For this last episode, I want to talk about one of the challenges in causal diagrams learning, which is measure common cause. We often describe common cause as confounder, so we are also talking about the issues of linear confounder. And notice that this is a quite open question, so there's no absolute solution to it. But in this presentation, I want to share some opinions of what I would like to call the philosophies of causal diagram. I always like to start with example from the Book of Why. So this time let's talk about education and salary. Say if we want to figure out whether there is some causation between, a higher educational degree and a higher payment of salary. And as a non-fact, a person's excellent working experience is definitely one of the cause contributing to getting a high salary, right? So at the same time, we are not quite sure if there have something between one's experience and education. So before we test in the causation between these two factors, we need to do some control experience about the other factors such as experience to remove their kind of bias, right? Um, but but let me just make a big addition because um in previous episode I said we should be clear about the behavior of controlling when we are calculate the control derivative as a natural derivative, right? But since in this example we are more likely to focus on the dependence between factors and we don't calculate a numerical values of causative effect. So to be simple, let's just use the word control. That is, we have some factor to be conditional. We temporary, don't need to consider the counterfactual thinking. Okay, let's move on. So we have to be clear of the potential mechanism. We are not sure about the relations between these two factors. That is, uh, let's break it down. If the situation is the experience will influence the education. That is, if you see someone's working experience, maybe that reflect one's competence, and that personal ability will help a person to more easier to battle their graduation study. And at the same time, it will help this person to uh, be more easier to be get appreciated by the employer so that they will get a high salary and maybe it's not have something to do between the education itself and the salary. So given that situation, it's okay you control this factor to remove the bias. That is, before you testing the people, before you testing your sample, you assign those people to different groups where each groups will share the same years of working experience, so that you make sure the people you're testing are under a same level of working experience. Always say the personal person's competence reflect from their working experience. Okay, and for another for the other situation, let's say if the mechanism goes like this, that is, if let's say if a person who might only got a bachelor degree, but the truth is those person um, they will they will trying to spend more time to hone their practical skill to accelerate their working experience after their graduation, so um, that will also make it more easier to get appreciated by the employer, right? So if the situation just goes like this, it's okay. You also control this factor and do your experience. But let's just make the situation a bit complicated. Let's say if now I add unknown characteristics to our graph, this is what we call the unmeasured common cause. And let me explain the situation. That is, um, you see these two factors. So that means if the situation is that the person you're testing just happened to, by some unknown factors, they just happen to have some connection with the company. Maybe they just know some people like the leading figures in the company. So this will make them more easier to get working experience to work in that company, and naturally they might be more likely to get high payment of salary. So you see in the diagram here, when you still control this factor, now this factor in the whole diagram is like collider. Um, if you still remember the concept of collider that I introduced in the previous episode, then you might know that the result of the collider is that you will open a door for the new confounding, and so especially that new confounding comes from an unknown characteristic. So it will create a superior connection between the factors you're interested in. So let me explain this better example. Maybe you have something, maybe you observe there might be a dependence between education and salary, but maybe the truth is it's quite specially. Maybe the man you're testing are working in a company running by his father or his uncle. I don't know, but I think that might give that man the opportunity to more easier to get the working experience and get a high payment salary. There might they might not have something to do between the education and salary. So to briefly summarize this, let me give you a panel. So I draw the panel here because I want to illustrate this. Just like our observation are just confined by this panel, we can only collect in data from the factor that that we can already measure, but but definitely there might have some unknown characteristics outside the panel, which might create some bias while we're doing experience. So even for okay, so I have to mention that this unknown characteristic is what we call the unmeasured common cause or Lennon confounders. But you see, even for the measured, the common cause we are able to measure, we still have the question is, should we control it or keep it unmeasured? That is, if we are sure that factor is a common cause, then we should control it, and this will help us remove bias. But if we are not quite sure the mechanism and we still continues to control it, then we might sometimes open a door to induce new compounding and probably from an unknown common cause. So this is to make it a bit difficult for the problem of about the Lennon compounder. And this is only one of the part. And in the next part, I'm going to show you what I call this the vertical. Let's take a perspective from this one.